Today's lesson has to do with the relationship between exponential and log functions, and we will learn how to evaluate log expressions today. In your new packet, page 1, we are doing WhatPower functions. So the question says evaluate each expression. What it's asking you to do is tell us what power do I have to raise 2 to in order to get 8 as an answer. Well, the exponent that 2 is raised to is 3. 2 cubed equals 8, so 3 is our answer. B, what power do I have to raise 3 to in order to get 9 as an answer? Well, 3 squared equals 9, so our answer to B is 2. 6 squared is 36, so the answer is 2 for C. For D, 2 raised to the 5th power is 32. 10 raised to the 3rd power. Remember, if your answer has 3 zeros and 10 is your base, then your exponent is going to be 3. 10 raised to what power equals a million? A million has 6 zeros, so 10 to the 6th power, 6 is your answer. For letter G, what power do I have to raise 100 to get a million? 100 raised to the 3rd power gets me the 6 zeros I need for the answer to letter G. So 100 raised to the 3rd power, 3 is the answer for G. H, 4 raised to the 3rd power equals 64. 2 raised to the 6th power is also 64. Now, J is unusual in that the base 9 is smaller than the answer 3. So you have to start thinking about rationals and radicals. What can I do to 9 to make 3? I can take the square root. And if you remember rationals, square root is the same as the 1/2 power. Remember, it's asking what power it is. It's not asking about radicals. What power do I have to take 5 to in order to make the square root of 5? Well, the square root of 5 is 5 to the 1/2 power, so I must be raising that base of 5 to the 1/2 power. For letter L, it's 1/2. What power do I have to raise that to in order to make 1/8? Well, if I cube 1/2, I'm going to get 1/8. 1 cubed is 1, 2 cubed is 8, 1 over 8 is 1/2 raised to the 3rd power. How do I go from 42 to 1? Well, anything raised to the 0 power makes 1, even 42. Yesterday, we talked about turning decimals into fractions. I would change 0.01 to 1 over 100 and say to myself, well, how do I go from base of 100 to 1 over 100? It must be 100 raised to the -1. From 2 to 1/4, 2 must be raised to a negative power to get that 4 on the bottom. And in fact, I'm going to have to raise 2 to the -2 power in order to take 2 and make it 1/2 and then square it to make it 1/4. So 2 to the -2 power is 1/4. For letter P, again, I'm going from a very small number to a large number, but this way I'm flipping in the opposite direction. To get 4 1/4 to be 2, I'm going to have to make a negative exponent. And then what else do I have to do to 4? To get 2, I have to take the square root. So I'm going to be taking the -1/2 power, 1/4 to the -1/2 power in order to make 2. For letter Q, you're to describe what went on with our experiment with what power. And you should write down and hit pause and say the value of what power base B is the number you need to raise base B to in order to get X as an answer. So if I think about it exponentially, that says base b raised to the L power equals x. So if then I make that the log argument, the answer is the exponent L. What power do I have to raise b to in order to get x as an answer? Well, that power, that exponent, is going to be L. More practice on page 2. I suggest that we think about the base this time. Think about the base, not the answer as much. I mean, obviously, we need the answer to come up with our answer to the what power, but we're exploring bases here, and I suggest you hit pause and try some of these on your own before you expose the answers as I am. What power do I have to raise 7 to make 49? I have to raise it to the second power. What power do I have to raise 0 to make 7? Well, that's impossible. There is no power I can take 0 to that results in 7 as our argument or answer. So this 7, this 49, is not only called the answer, it's also called the argument. What power do I have to raise 5 to in order to get 1 as an answer? That's going to be the 0 power. Anything raised to the 0 power is 1. 1 raised to what power equals 5? That's also impossible. There is no power I can raise 1 to that doesn't give me 1 as an answer. So since the answer is always 1, the argument or answer to number 4 can never be 5, not possible. 2 raised to the 4th power equals 16. So the what power answer is 4. Negative 2 raised to what power is 32? Well, I would think it would be 5. Unfortunately, negative 2 raised to the 5 is negative 32. I am never going to get a negative answer for my argument or my answer. So the 32, where that argument is never going to be negative. 6 is not possible. 1/3 to what power is 9? I'm starting with a small number and making it bigger. So that usually means I need to do an integer exponent, but since the 3 is in the denominator, I need to make that exponent negative to get it to the numerator. So first I'm going to flip it with a negative, and then I'm going to square it. So negative 2 is the answer to number 7. Number 8, what power do I raise negative 1/3 to make 27? Well, remember, if I cube negative 1/3, I'm going to get a negative answer, even if I flip it. So 8 is not possible. So what do we talk about in terms of allowable bases? This little number b, what is possible and what is not? Please write this down at the bottom of page 2 in your packet. In the what power b gives an answer of x function, b must be greater than 0, but not 1. So think about this. It's like your exponentials. Your b, your base, can be between 0 and 1, and your b can be greater than 1. It cannot be negative, and it cannot be 1. So we mostly define our bases as I said, between 0 and 1 or greater than 1. And then in terms of defining our x values, our answers or our arguments, those have to always be positive. In that parentheses after 1 power, it can never be negative and it can never be 0. Pause here if you didn't have a chance to write that down. Next page is a Freyer diagram, where we're going to talk about what we learned in the last 2 pages. So our definition of logarithm base b comes from the previous page. What we wrote down on the bottom of page 2 is our base is never negative, 1, or 0. It can be between 0 and 1. It can be a fraction, but it can never be negative, 0, or 1. Our argument, that is this part of our log. So keep in mind, our what power is now defined to be a logarithm. What power is an everyday word. Logarithm is the math word you need to do these problems. So we learned that our base can never be negative 1 or 0, and our argument must be positive. In terms of our characteristics, we need to talk about what's possible. When our argument is greater than 1, and our base is greater than 1, we're going to get a log value that is positive. When we have a base that is a fraction between 0 and 1, and our argument is 1, then that means we have to make our log value, our exponent answer, we need to make that negative. When our argument or our answer is between 0 and 1, it's a fraction, and our base is greater than 1, then again, our log value or our exponent needs to be negative. And lastly, if our argument is a fraction between 0 and 1, and our base is between 0 and 1, that log value is going to be positive. So in terms of our definition of logarithm, let's try to remember that b raised to the x power is our answer to a logarithm, and our logarithm answer is an exponent. And this is I think I got that wrong. Sorry, hold on. This is the base, this is the exponent, this is the answer or argument. In terms of our log, it's going to be log, our base is going to be here, our argument or answer is going to be here, and the answer to every log is an exponent. So this is your exponent. The answer to every log is an exponent. Our examples of where logs work come from the previous pages, right? You don't have to do this. We did that in our top right box. You can give examples of where logs work. 2 raised to what power equals 8? The answer is 3. 5, log base 5 of 1. What power do I have to raise 5 to get 1 as an answer? That exponent is 0. What power, or log base 10, what answer gives me 1 over 100? So remember, if you've got 10 and your answer is a fraction between 0 and 1, your log or exponent answer is going to be negative. So you need to flip it, and then you need to square it in order to make 10 1 over 100. Lastly, we have our non-examples. Where don't logs work? You cannot have log base 0. You cannot have a negative log base, and you cannot have a negative argument. That's not going to result in any exponent you know. Pause as you need to copy this down. I'm going to bring it up a little bit so you can see everything. When you're finished, move on to the next page. More examples of logs. Hit pause. Do these problems. Read the problem. Think about what it's asking for and give the answer. 2 raised to what power? Log base 2 of 8. 2 raised to what power equals 8? The answer is 3. Log base 3 of 9. 3 squared equals 9. Log base 6 of 36 says I need to take 6 to the second power. Remember, your answer is always an exponent. Log base 2 of 32. 2 raised to what power is 32? That's 2 to the 5th power. Answer for 4, exponent 5. 10 raised to what power equals 1,000? Log base 10 of 1,000 is 3. There are 3 zeros in 1,000. 42 raised to what power equals 1? It doesn't matter what the base is as long as it's not negative of 0. anything raised to the 0 power is going to be 1. So the answer 1 comes from 42 to the 0 power. Number 7, remember you're going to change that to 1 over 100. So in order to flip it and then square it, oh, I'm sorry, you just have to flip it because 0.01 is 1 over 100. So that means I'm going to take 100 to the -1 power. Log base 2 of 1/4 comes from, what do I have to do to 2 to flip it and make 4 in the denominator? That's going to be 2 to the -2 power. I'm going to save these last ones for class on Tuesday. Have a good weekend. See you then.